Hello and welcome. Today I'll be explaining linear equations. By the end of this video, you'll be a pro at being able to draw these graphs, to be able to look at these graphs and figure out what the equations are, and to figure out what the x-intercepts, y-intercepts, and gradients are. We'll start off with the most important form of this equation, and that's what we have here, y equals mx plus c. Now I'll explain to you step by step what each one of these letters means. So this c that we have over here is our y-intercept. And it tells us when our graph crosses this y-axis that we see on the right side over here. So for example, if that number there was 5, our graph would be going through 1, 2, 3, 4, 5, right here. It would go through that point there exactly. Okay, so that's what that tells us, our y-intercept. Next we have our m here. This is our gradient, also known as rise over run. And what that means is how much our graph goes up by how much it goes across. So for example, if our m was 2, that would mean our rise over run is equal to 2 over 1, which means for every 2 that it goes up, it goes across by 1. So before we had our graph go through 5, if we want to see what our next point would be, it would go up by 2 and across by 1. And you can see how our next point would go through that. And then our next one would go up by 2 again, and then it would go through there. And then if you just draw a line that connects all of those points together, that's it. That's the graph completed. That's how you draw the graph. Now this x here is our input. It's what we put into the graph. So you might pick 1, or you might pick 2, or you might pick 3. It's whatever number you pick to put into the equation to work out what the number becomes. And then y is our output. It's what our number becomes after we put it into our graph and work out the operations. So for example, I'll use a real life example to make this a bit more clear. So imagine you've already spent $4 on drinks. You've already spent that. And you're going to your friend's house and they want you to buy some chocolates, and the chocolates cost $2. If your friend wanted you to buy one chocolate, how much would you spend altogether? Well, that would be $2 per chocolate times 1, because you're only buying one chocolate, plus 4, because you've already spent $4 on drinks. And you can see how that gives you $6 total. Okay? Now, what if they told you to buy 2 chocolates? Well, then you would go and you can see how that would give you 8. Okay, so we can make an equation out of this. And I'll color code it again so you can see. So our cost is red, so that's our y value. Our $2 for the chocolates is our gradient. Our x is the number of chocolates that we buy. So number of chocolates. And then our y-intercept is 4, because we've already spent $4. So you can see how our graph has this equation. Okay, so that's what our equation is. This is how many chocolates we buy. This is how much each chocolate costs. So how steep our graph is. This is our y-intercept, and this is our output, or our cost. And I'll show you how to sketch this graph now. So 2x plus 4, let's move it down here. And I'll show you how to sketch this graph right now. So first we look at our y-intercept. It says 4. So we'll go 1, 2, 3, 4. Our graph goes through that point. Okay. Then we look at our gradient. That is 2 over 1. So rise over run means that it goes up by 2 and across by 1. So our next point is there. We only need 2 points, that's it. Then you just use your ruler and draw a straight line through those points, and that's your whole graph completed. Okay, that's how you draw the graph from the equation. Now, sometimes they might give you a negative gradient. That won't really work in this scenario because we're talking about cost, but sometimes you might come across that. So I'll do an example of that as well, so it makes a bit more sense. So imagine we had -3. And I'll just change the y-intercept as well. So in this case, what we're going to be getting is a y-intercept at 2. So you can see how our new y-intercept is 2, goes through that point. Now the only difference is our gradient is -3, which means it goes down by 3 for every 1 that it goes across. So if we count, we get 1, 2, 3, and 1 across. So that's our next point. If you just connect those 2 points together, you get your graph. And that's it. That's how you draw it. Okay. Now I'll show you a couple of examples where you have the graph and you need to figure out the actual equation itself. So in this scenario, you can see that our y-intercept is 1. So immediately I'm going to write +1 at the end because that's our important piece of information. So I'll write the template up here just so you can see. So that's our y-intercept. Then we just need to work out the gradient. Now to figure out the gradient, you just pick 2 points that are easy for you to look at. So I can pick this point here. That's 1, 3. And this point. This is 2, 5. Now what you can do is just count. You can just go, how much does it rise by? Rises by 2. And how much does it go across by? 1. So that's our gradient. And that's all you get. Sometimes you might not be able to count because there might not be a nice grid for you to count on. The other way to just work it out just using the coordinates themselves is like this. You can write the top coordinate there and then the bottom one under it. And then you just work out the rise and the run separately. So the rise is the y values, so you just minus them. So you do top minus bottom over the run. So again, you do top minus bottom. And you can see how that gets you 2 over 1. So our gradient is 2. That's what we got before from counting. But this is just another way of working it out. So if you have any 2 coordinates on this, you can pick any 2 that you can see and just do the same minusing that I showed you. You'll get the gradient. So our final graph is y equals 2x plus 1. So we'll do another example where the gradient is negative, just so you get a really good idea. So I'll write the template again, and we'll look for our y-intercept first. So hopefully from here you can see that our y-intercept is 2. That's really good, so you can write 2 there. After you've done that, just pick 2 coordinates again that we can easily see. So they can be any. So this one is 0, 2. And this one is 1, -1. And we can just count again. We can just go 1, 2, 3. So it goes down by 3 and it goes across by 1. So our gradient is -3. But we can do the coordinate method as well, where you just write the top coordinate there, the bottom one under it, and then do rise over run separately. So the rise is that y value minus that one. And then the run is this y value minus that one. So you can see how on the top we get 2 minus 1, which becomes 2 plus 1. So you get 3. And then the bottom is just -1. So you can see how both of these give us the same gradient of -3. You just write your x there and your y there, and that's your answer. Sometimes you might come across a graph where the gradient isn't as nice, and I'll show you that here. So again, we want to start by looking for the y-intercept. We can see that it's 1, 2, 3, so it's -3 because it's downwards. Now that we know that it's -3, we can write that comfortably here. Now we just need to figure out the gradient. So again, you just pick 2 coordinates any two coordinates and just compare them. So I'll pick this one here. This one is 0, -3. And I'll pick this one here. This one is 2, 0. So again, we can do our counting method where you just count how much it rises by and how much it goes across by. So it goes up by 3 and across by 2. So our gradient here is 3 over 2. So you can see how it's not a nice whole number, but you can still get a fraction, and that's completely fine. No need to stress. And we can do our method from before as well, which is you just write the two coordinates, and then you just do the rise over run separately. So you go this one minus this one over this one minus this one. And that gives you -3 is +3 over 2. Okay, so we get the same answer as before, and our answer is y equals 3 over 2x minus 3. Sometimes you might come across an equation that looks like this. This looks really different from what we had before. Before we had y equals mx plus c. And we had y by itself, and that let us really easily see what our gradient was and what our y-intercept was. So all we need to do when you get an equation like this is to get the y by itself, and you'll easily be able to see the gradient and the y-intercept again. So first, we just need to locate where the y is and understand that we need to move this 3x to the other side. The way you move it to the other side is just by doing the opposite of what this 3x is doing on this side. So this side, it's a positive 3x. So the opposite of that is a negative 3x. So we take away this 3x from here, and we take it away from this side as well. And when you do that, you can see how you get 2y is equal to 6 minus 3x. Okay? Then finally, we need to get rid of this 2 here, so we get the y by itself. And what the 2 is doing there is it's timesing by the y. So you need to divide it. So you divide by 2 and divide everything on that side by 2. So you get y equals, and now be very careful because you need to divide everything on this side by 2. So you divide the 6 by 2, and when you divide the 6 by 2, you get 3. And then you need to divide the -3 by 2, and then you just get -3 divided by 2. I like to write this separately. So I don't like to write all over 2 because that makes it less clear on what the gradient is. Okay, so this way makes it really clear. Now I hope you can see how this is the gradient. I can write this in a separate order, so I can just bring this 3 to the end here. It has a plus in front of it naturally. And then I can just write this -3 onto x in front. Okay, so all I did was just switch the order there, just so you can see how it matches up nicely with our original template. So you can see how our gradient is -3 over 2, and our y-intercept is 3. And using that information, you should be able to sketch this really easily now. Okay, so if you ever come across an equation that looks like this, don't stress, just rearrange it and get the y by itself. Now, it's really important to also be able to figure out what the x-intercept is as well. And I'll explain to you what the x-intercept is as well. So if we have this graph, which is one of the graphs we looked at before, I'll just draw it really quickly here using the steps that I showed you. So we know our y-intercept is 1. So we know our graph goes through here, and we know our gradient is 2. So it goes up by 2 and across by 1. So it goes through these points that you can see. Okay, and you can just draw it up as well. Just use a ruler. Now, our x-intercept is when our graph crosses this line here, our x-axis. You can look at it and you can see that that number does look like -1/2. But how do you actually figure that out? Well, what you do is really simple. You just make the y value equal to 0, because there you can see how that point is not up or down. So the y value there is always going to be 0 at the x-intercept. And then all you do is you just rearrange this and get the x by itself. So how do we rearrange this? We do the opposite of what this is. So you -1 from both sides. And then we do the opposite of what that 2 is doing to the x. So right now it's timesing, so you divide by 2. So you can see how you get negative a half is equal to x. So that's telling you that that value there is negative a half. So if they ever ask you for the x-intercept, just make the y value equal to 0 and rearrange the equation until you get the x by itself. So another type of question they can ask is when they give you two coordinates, such as 2, 3 and 6, 4, and they ask you to find the equation of the graph. Now, what you can do is you can plot these points and then have a look and then try and find the equation of the graph using the technique that I showed you before. So we could go 2, 3 first. This is 2, 3. And then 6, 4. Where is 6? It's there. And then 4 is here. And then what we can do is draw a line through that. And continue this line. And now you can have a look at it. But the thing is, it's hard to know what that y-intercept is. Now, it looks like 2.5, so we could use that. But what you should do is first find the gradient using the subtraction method that I showed you before. So first you do rise, and that's always the y values minus. So we'll do this one minus this one. So that gives you 4 minus 3. Then you do run. So that's this one minus this one. 6 minus 2. So that gives you 4 minus 3, which is 1. And then 6 minus 2, which is 4. So you can see our gradient is 1 over 4. What does that mean? It means it goes up by 1 for every 4 that it goes across. So you can see that here. It goes up by 1 and then goes across by 1, 2, 3, 4. Okay, so that's what that means. But it's kind of hard to see it because sometimes you might not have an axis like this. It might not be a nice grid for you to count. So knowing this is important. Now, we can guess that the y-intercept is 2.5, but how would we actually work that out? So if we put our gradient into our equation here, so we put 1 on 4 where m is meant to be, and we have our plus c. What you can do is this. You can pick one of these coordinates. I'll pick the easier one with smaller numbers, and you can put it into this equation. So we know this one here is the y value, and this one here is the x value. So what I'm going to do is I'm going to put this as our y value here. And then I'm going to put this as our x value here. And now you can see what happens is we get a quarter times 2 is a half plus c, and we have 3 here. Now all we need to do is just solve for c. So you just move this a half to the other side by subtracting it. So you do minus a half here, minus a half here. So you get c is equal to 3 minus a half, which is 2.5 or 5 on 2. Okay, so 2.5 is what we had before. That's what we guessed. Okay, but this is a good way to where if you have two coordinates, you can solve and find the equation without drawing the graph. Okay, so our final answer is y equals 1 on 4x plus 5 on 2. I hope that helps. Okay, now we'll look at something that's a bit more of an extension. This is parallel lines and perpendicular lines. So parallel is when you have two lines that travel together like this and they never touch. Think of it like train tracks. Okay? And the special thing about these lines is that they have the same gradient. So they have the same slope. And that should make sense. If one of them is going up by 2 and then going across by 1, according to this, the other one is doing the same thing. That means that they have the same gradient. Okay, so if they ever ask you which one of these graphs is parallel to the one above, and you have these options, all you do is just pick the one with the same gradient. The y-intercept does not matter when talking about parallel. Now there's one more thing, and this is perpendicular. Now perpendicular is when a graph makes a perfect 90-degree angle like that to another graph. So in our example here, a perpendicular graph would be this one. And in this case, the y-intercept doesn't matter as well. It's only the gradient that we care about. And the way that you find the perpendicular gradient is very easy. All you do is you get this gradient and you flip it. So remember, whole numbers are normally over 1. So you flip it and you make it a half and you put a negative in front. That is how you get a perpendicular gradient. So for example, if my gradient was -3, I would flip it. And then putting a negative in front of that would cancel out the negative in front already. And that would make it positive 1/3. Okay. Another example, if the gradient was 2/3 and you want a perpendicular gradient, you would flip it and put a negative in front. Okay. So let's do an example and show you how the perpendicular line works. So if I had an example like this, y equals 3x plus 1. Let's use our skills from before to sketch this. So looking at this, our y-intercept is 1 and our gradient is 3. So it goes up by 3, 1, 2, 3, and across by 1. So you can see how that's the next point that the graph goes through. So I'll put a point there, and now I'll just draw a straight line through those points. So you can see how this is our graph. Now, looking for a perpendicular line, all you do is you get this gradient and you flip it and you put a negative in front. That's all you do. Now, the y-intercept can stay the same. It doesn't really matter. The y-intercept can be different. Since the y-intercept is the same, it'll still go through 1, but the difference is our gradient. So you can see how the rise is -1 and our run is 3. So what does this mean? It means it goes down by 1 and it goes across by 3. So you can see how our next point is there. Okay. Once we have that, we can draw a line through there. So use your ruler to draw a nice straight line, and you can see how once we've drawn both of those graphs, we have a nice 90-degree angle there, and that makes these graphs perpendicular to each other. So now I need to show some common mistakes that a lot of students do that I really do not want you to do. So using the same example as before with these two coordinates, when they ask you to find the gradient, it's really important to make sure that you minus in the right order. So when we're doing the rise over run calculation, where we minus the y values, it's important to do this. So 4 minus 3 and then 6 minus 2. Do you see how the arrows are in the same direction? So if I do 4 minus 3 over 6 minus 2, that'll give me 1 over 4, which is the right answer. As long as the arrows are in the right direction and you're minusing along those arrows, you will not get it wrong. So for example, even if I do it the other way, 2 minus 6, 3 minus 4. Look, as long as the 3 minus 4 is at the top, because that is rise, and then 2 minus 6 is at the bottom, you'll get -1, -4, two negatives cancel out, and you get +1 on 4. So you get the same answer. Okay. The only main mistake that people make is when these arrows are not facing the same direction. So do you see how that's not the same direction? You can't do 4 minus 3 and then 2 minus 6. It won't get you the right answer. It'll get you -1 on 4. That's not our answer. So as long as your arrows are in the same direction and you minus x from the x and y from the y, you will not get it wrong. Another mistake is knowing which direction the graph is going if the gradient is positive or negative. Okay, it's a really, really simple one, but it's just really important to remember that if it's positive, if the gradient is positive, so for example, if we have y equals 2x, it's important that you understand that the graph is going upwards in this direction. Okay, it needs to go from bottom left to top right if it's a positive gradient. If it's a negative gradient, then it goes from top left to bottom right. Okay, so if that number in front of the x is a negative, then it goes from top left to bottom right. Thank you for watching. I hope that was helpful. Please email me if you have any questions and let me know in the comments what I should explain next. Thank you for watching.